What do you mean take out one of them?
Like, could you, it sounds like my tongue, like, not distribute, but like, pull it out of there?
Pull what out?
Factor, can you factor it out?
Can I somehow factor?
Yeah, so then.
Factor this?
Yeah, can you factor that?
I can factor it, but how do you factor it? This is the right way. How do you factor this, everyone? There's not a cosine in both of them. Let me ask you this. If I asked you to factor this, could you? Could you factor that? What is that factored? X plus 2, x minus 2. What do we call that? A difference of squares, right? That's a difference of squares. So you could factor this, yes? What if I changed the problem, I made it 1 minus x squared? Could you do that? Could you factor that? What would it be? Careful, it's not, it's the order matters here. So this would be 1 plus x, 1 minus x, right? This is a difference of squares. What formula am I using? I'm using this formula. A squared minus b squared is a plus b times a minus b. That is your difference of squares factoring formula from college algebra, pre-algebra, right? Difference of squares. Do you see a difference of squares right here? Do y'all see it or not? Is 1 something squared? Yes, it's 1 squared, right? Is cosine squared something squared? Yes, it's cosine squared. So let me write it down. What's 1 minus cosine squared theta written in its difference of squares factored form? 1 plus cosine theta, 1 minus cosine theta. Right? That's what that is. If you were to FOIL this back out, 1 times 1 would give you 1. The middle terms would cancel. The last one times the last one would give you negative cosine squared theta. And that's exactly what we have there, right? Why is that? Is that even worth our time? Is it even worth our time to rewrite this as a difference of squares? Is it? What happens if I rewrite the top as 1 plus cosine theta over 1 minus cosine theta? What? This and this are exactly the same thing and they cancel.
Yeah.
Right?
Yep.
So this whole factor cancels with that factor. So that works. And we should be looking for that from now on, right? Difference of squares like that. So this becomes, I still have the 1 there. I have minus. And then once I canceled these out, you know what I'm going to do? I'm going to write this again just so you see it. This was 1 plus cosine theta times 1 minus cosine theta. This was all over 1 minus cosine theta. So that's me using the difference of squares on top. And then this and this go away. So I have 1 minus, in parentheses, 1 plus cosine theta. Very important that this minus here gets distributed through to both these terms, because we're going to have 1 minus cosine theta. 1 minus cosine theta. And the 1's cancel, and now you're left with the right-hand side. All right, so this is your opportunity to ask questions. This isn't necessarily right now something where you should be like, well, you know, how am I ever going to see that? I would have never seen that. Okay, fine, you would have never seen that. Now you've seen it, right? So the point is not, could you come up with this on your own on the first try? It's now that you've seen it, do you understand? Are there any parts of this that you're unsure of how we got from one step to the next? Y'all are okay? All right. So you know how I've been talking about turning the screws, right? Yeah, we talked about that? Did I tell you that my calculus class got on to me about that? About the turning of the screws? They told me I was sadistic, no? Did we talk about turning the screws? No? There's a phrase, turning the screws. It comes from medieval torture devices. Have you ever heard of the rack? Where they just tie someone up, feet, and just start turning, pulling them apart, torturing them? No? Believe in my God. Do you believe my God? No? I'll keep turning. You believe my God yet? You know what I mean? That sort of thing? Okay, so these torture devices, usually there would be some mechanism where they turn it, it would get worse and worse for the person. Right? Turning the screws is like slowly increasing the pressure. Anyways, I was telling my students about that, and they were like, "You're sick, man." And then I heard it I was watching a baseball game the other day, and they used it. And I'm like, I am sick, but I'm not the only one using that phrase. All right, here we go. I'm turning the screws. I shouldn't say I am, all right? The book is turning the screws. All right. First things first. Those are V's, okay? Those are V's. And as you proceed in your mathematical life, you'll probably want to make some adaptations to the way you write things. You may have already had to do this. I used to write my V's more like, I don't know, I was kind of lazy with them. They started to look like my U's. So like that's a U and that's a V. And so I started to put a tail on all my U's so that you could distinguish it from a V. And on my V's, I'm very particular about getting a nice sharp corner on there so you don't think it's an R, right? Little things like that. Like if you write the letter T, do you write T like that? Or do you write T like this with a little curl on the bottom so you don't think it's a plus? When you write your 2's, do you write 2's like that? Or is that a Z? Is it a Z or a 2? Strike your Z's, then you know it's a Z from a 2. Those little things, right? Especially if you want to plan on being like an engineer or something like that, you're going to be doing a lot of writing of math. These little things matter later because you don't want to look at your own work and be like, I don't know what that is, right? So I'm just telling you, these are V's, all right? So cosecant V minus 1 over cosecant V plus 1 equals 1 minus sine V over 1 plus sine V. Man, it's already 2:16. We could spend a month doing problems like this, right? We're not going to, but we could spend a month just doing problems, identities over and over and over. Well, left-hand side. What do you want me to do on the left? What makes the most sense? I heard something. What? Get them all the signs, right? This is 1 over sine, that's 1 over sine, right? May as well, shoot, we're trying to get to sines, right? So let's start with the left-hand side. I'm going to rewrite that as 1 over sine V minus 1, and then on the bottom I have 1 over sine V again plus 1. These don't cancel, right? These don't cancel, these don't cancel, right? Those don't cancel. Okay, that's a legal move, right? That's fair. Starting here, we got to here. Now, what would you like next?
Multiply sign into both top and bottom.
You want to multiply sine on the top and bottom, like of the whole thing? Like a sine over sine like this?
Yes.
Holy shit. That's going to work. How in the heck did you see that? Multiply top and bottom by sine. Whoa. That's going to work. Do y'all see that that's going to work? Look what happens. Sine, that's a 1, right? I can multiply by 1. Okay, sine is going to come, sine v is going to hit this and become a what? A 1, right? They're going to cancel. The signs are going to cancel. Then I'll have minus, and then it's going to hit here and become what? Sine v. So I'm going to have 1 minus sine v. Hey, look. And then down here, here to here, it's going to be a 1. And then here to here, it's going to be plus sine v. How do you see that? How do you see that? Tell us, please. Yeah, I can't. I just can't. I can't teach that. I can only show you, and then you can start to pick up on it. And then some people are going to start taking that leap and getting it, and others are going to take a little longer. But I promise you, if you're persistent, it'll come. It's just you're going to have to put time into it. So this is great. This is a really good move right there. So let's do it. Let's multiply through here, and then here, and here. And that's going to take us directly to it, right? Directly to it. Boom, right-hand side. We're there. By realizing, I don't know, were you looking at where you were trying to go, or no?
I was kind of playing chess, I guess.
Okay, just kind of threw it out there and hope for the best?
Well, I did look at it, but then I could also multiply into it. And then while doing that, I looked at what I was trying to get. And I was like, oh, it works.
Yeah.
So kind of played out.
Yeah. Here's another way. A lot of students, I see students do this as well. I don't want any of you to be discouraged with this. Now, if you go home and you can't do one problem, okay, then you should get help and we should talk, okay? But you got to practice. You got to just try, all right? I see a lot of students try to get common denominators. So like they say, all right, I'm going to try and put those two together, right? So they change that 1 into sine v over sine v. That's legal. That's fine. And then here, the same thing. They change that to sine v over sine v. Does that make sense to do that? On the top, we can put those together. This is 1 minus sine v over sine v. And the bottom becomes 1 plus sine v over sine v. See it? Put those together. And then a fraction over a fraction, you can flip this one up, right? So if I flip that one, that's the numerator. Then I'm bringing this one and flipping it. So now the sine v is on top, and the 1 plus sine v is on the bottom. And the sine v's cancel, and you get what you were looking for. So that's another path, right? Not quite as efficient as this, but still got you there, right? Cosine v over 1 plus sine v plus 1 plus sine v over cosine v equals what? 2 secant v? What the hell? Really? That's what that is? All right, I believe you. Yes.
I just have a question.
Yes.
Would we ever expect to see it not be true, or there?
Oh, no. All of these are prove this identity, so they're all true. Yeah, that'd be terrible, wouldn't it? I remember in graduate school, I had a problem that we were given to work on, and in grad school, everything's take-home exams. Nothing is in class, and so it was this problem I'd been working on for probably 8 weeks, right? And it was just one problem, and it was prove something, right? Like this, like prove. It wasn't an identity, but it was like a proof, right? Prove this is true. And I was actually able to find a counterexample that proved that what I was being told to prove wasn't true, right? Does that make sense? So then I I went and I proved it a different way, said, long story short, I went to the professor, and this professor, he is notorious for don't approach him, don't ever go talk to him because he'll get pissed off. So I went to his office, sir, you know, and he's in there with like a pipe. What? You know, what do you want? You know, I was annoying him just by being there. So I went in and I said, sir, here's what you asked me to prove, and here's a counterexample, and then if you change these two numbers, then you can prove it. Here's the proof. And he looked at it, he's like, oh, that's a typo. Tell the rest of the class. Shit. But I will tell you, I learned more with his mistake than I would have had it not been a mistake, because I had to be so certain that it was a mistake, right? Before I approached him, I had to be 100% sure, because if not, I was afraid what he would have done to me. But that's not going to happen here, okay? Unless the book has a mistake, they're not going to give you something and be like, show this is true, right? So you can be rest assured with that. Dr. Wilson. There was a kid in the class, not that class, it was another class called Number Theory. And right in the middle of the lecture, this kid's like, hey, sir, why do we have to know this? You know that question, it's a common math question, right? Why do we need to know this, right? He stopped the class, took the kid out of the room, he's gone for 30 minutes, came back, continued lecturing. We found out he took him to the bursar's office and dropped him from the class. Holy shit. But it was a math class, right? So math majors, don't ask why. You signed up for it, right? You're there to learn, so. All right. I'm just blabbing while you're looking at this, trying to figure out your path, right? I'm going to make sure I wrote it down right. That's one thing you do want to make sure you do is copy the problem down correctly, because if you mess that up, then you might be trying to prove something that's not true. Cosine V, 1 plus sine V, plus 1 plus sine V over, yep, that's right. What do you think? You want to do what?
So the 1 plus sine V.
Can you turn 1 plus sine V into something with cosine? I don't know, can you?
No, because it's a square.
Yeah, so it's not squared, and there's not a minus. You would need a minus, right, in order to go? But I'm glad you're asking, because those are the things you need to like look and say, I can rule that out, right? I can't turn that into a cosine. Sana, what'd you say?
I don't know. Can you like multiply the top and bottom?
How do you mean? I want to do what you're asking me to do here. What do you mean by multiply top and bottom?
Like multiply cosine with 1 plus sine.
So you want to put these together somehow? They're added, which means you need same denominator, right? Can you get me a common denominator? Like what would you need over here? Cosine V, top and bottom, right? And then over here, what would you need? Okay, let's do that. Now, is it going to get us anywhere? I don't know. But no, I'm not saying it's wrong. It's actually right, okay? I'm acting like I don't know if this is going to get us anywhere, because you don't know if it's going to get you anywhere, right?
Say we have to do something else. I'm going to know it's wrong.
Okay, all right. Ready? So Sanaa is saying, let's get a common denominator. May as well, right? We don't have a Pythagorean. There's no way to change this into cosine. There's nothing straightforward, right? Getting a common denominator is not an illegal move, right? So let's start with the left-hand side. I'm going to multiply top and bottom of this first fraction by cosine V over cosine V. And yeah, if this doesn't work out, it's not my fault, all right? All right. So we're going to start having fun now. So I can just blame it all on you. All right, so I'm multiplying by 1 plus sine V over here. 1 plus sine V. That's what you told me to do, right? This is it? All right. We just have to be a little careful here, because when we do this, we have to, when we're multiplying here, this cosine V is going to have to distribute through if we're going to do this, right? Or we leave them apart with parentheses around this. So I think just initially, I'm just going to start putting some parentheses around where I have two terms. I'm not going to multiply, I'm not going to distribute, but I will put these together. Here, those are two terms, and I'm going to have to multiply to put those two together. And then down here, same thing. I'm going to just kind of keep that in parentheses. Let's see what happens here, right? This looks like it's going to be a mess, but let's just try it. So when you multiply those two, what do you get? Cosine squared. Well, that's kind of good, right, to see a cosine squared? Because in our answer, right, we've got secant, and secant is cosine, right? So at least we have that. Cosine squared v over the common denominator, which is cosine v, 1 plus sine v. And then plus, now when I multiply, okay, everyone clear that that's just these two together, right? So now, yes? Is your idea? Yes? Okay, and then over here, FOIL. Can we FOIL that? So what do we get? First one, we get 1, then sine, then sine, then sine squared. So what would my top fraction over here be? 1 plus, how many sines? 2. 2 sine x plus, v, sorry, v. And then plus sine squared v, and then all over cosine v sine, 1 plus sine v. Oof. All right, that's what it is, right? Now can we put them together? They have the same denominator, right? Okay, put them together. So that'll be cosine squared v on top, plus 1 plus 2 sine v plus sine squared v all over cosine v times 1 plus sine v. Wow. Somehow this becomes 2 secant v. Does it? We got to keep working here, right? Keep working. Anyone see it? Sana, come on. I'm going to pick on you some more because, yes, you do. Yes, you see it. Look at the numerator. Oh, hold on. What's that, Sana? It's cosine squared v plus sine squared v. 1. Good. Does everyone see that what I circled is a 1? Okay. That's good, right? That simplified a lot of things, didn't it? So I have a 1 here, right? That's a 1. Plus, I have a 1 still, right? Plus 2 sine v. That's the only thing that's left on top, right? Over cosine v, right? Cosine v, 1 plus sine v. I want you to start looking at this answer. What is this really? What is that really? 2 over what? Cosine of v, right? That's really what that is? Because secant v is 1 over cosine. So this is really 2 divided by cosine of v. Do y'all see that we're getting really close to this? Here's cosine v. Do y'all see we have a 2 right here? I mean, we have two. Okay, we're getting there. Let's put those together. Come on. We're going to get this. We only have 8 minutes. 2 plus 2 sine v over cosine v, 1 plus sine v. Who sees the next step? It's something really simple. Cosine. I wish this wasn't here. I really wish 1 plus sine v wasn't here, right? Because my answer doesn't have that there, does it? Yes. There you go. Do y'all see that these both have a 2 in them? So you can factor 2 out. If you factor 2 out of here, what are you going to be left with on top? 1 plus sine v, and you have a 1 plus sine v, and they will cancel. It's almost like magic, right? So I've got now 2 comes out. I'm left with 1 plus sine v. And then over, I had the cosine v on the bottom, and then 1 plus sine v again. Now they can cancel. Because they're factors, right? This is multiplied, multiplied. You can cancel factors. And that's the answer, isn't it? This is the right-hand side.
I got it right.
You got it right.
Snap.
You made the right first move, right? By trying to put the common denominator.
That should be like my.
So your PhD thesis? Yes?
When we factor the 2 out, why
Yeah.
is there still a 1 plus sine v on the derivative?
There is. Why is there, or?
Like why, like I just thought that when we factored the 2 out, I don't know, I just.
Well, a 2 would come out of this, right?
Yeah.
And a 2 comes out of this. So when you pull a 2 from here, you're left with a 1. And pull a 2 from... Just think about it. If you distribute this back through, right? Here and here, you get 2 plus 2 sine v, right?
Yeah, I see it that way now.
You see it that way? Okay. All right, we have 5 minutes, 6 minutes. It looks like we're not doing a quiz. So we'll have 3 quizzes next time. No, we won't. Let's try one more. Let's just try and see if we can squeeze one more in here.
So was there an easier way to get that or no?
Actually, I have no idea. I don't think so. There might have been, but I don't see an easier way. Like me looking at it right away, I don't see something easier than a common denominator. All right, let me tell you what your homework's going to be, and then we'll do one more problem. So I'd like for you to look at, again, this is just going to be out of the ebook, not online. Especially online, right? How do you, it asks you to prove an identity. How do you prove an identity, right? Because it's already equal. So online, there's really no work. You just say, yeah, it is. It's true. All right, so what I'd like for you to do, problems 21 through, let's go for broke here. 21 through 71. Oh, 21 through 71 odds. And this assignment, there's 100 problems here. I'm going to go and pick a crazy one right now. This is going to be way in the back. This one, just see how you do there. And look, that's a ton of problems, right? If you feel like you're getting like the first few, they're okay, these all look the same, I'm not going to do any more, that's fine, all right? But you want to at least do, this is page 658 in the ebook. Yeah, sorry, page 658. Page 658 in the ebook, 21 through 71 odds. I mean, I want to be realistic here. I don't really expect that you're going to do, what is that, 25 problems or so by next class? Maybe not by next class, but you want to definitely get through those by the weekend, by the end of the weekend next week. Let's try this one. Sine theta plus cosine theta over sine theta minus cosine theta minus sine theta over cosine theta equals secant theta cosecant theta. Bless you. What do y'all think? Left-hand side, what do you want to do? Does this not look a lot like the last one in the sense that we could get a common denominator? I don't see any squareds anywhere, so I'm not thinking Pythagorean yet. So I would have to multiply this one by cosine theta over cosine theta. And then this one here I'd have to multiply by sine theta over sine theta. Understand? If I'm going to get a common denominator, that's what I would need to do. I would have to distribute this through, and then over here I would have to distribute the sine through here. Oh, this actually is going to work out really, really, really nice. I think this one's going to be easier than the last problem. Any questions on what I'm about to do? My first term here is just cosine theta times sine theta, whatever that is. Cosine theta times sine theta. And then when I go here to here, I get plus cosine squared theta, right? And then over my common denominator, which is just cosine theta sine theta, minus here, and then now distribute here to here, is cosine theta sine theta. Here to here is minus sine squared theta, all over my common denominator. I can put those together now, can't I? Be real careful. When you put these together, this is all going to stay here, right? And then this is minus that. So this minus sign has to distribute to both of those, right? So it becomes minus this, and then minus minus becomes plus that. I'm writing too big. All right, so I have cosine theta sine theta plus cosine squared theta minus cosine theta sine theta plus sine squared theta, all over common denominator cosine theta sine theta. You see it or no? What do you see? What do you see? Cosine squared theta plus sine squared theta. 1. Those two together are going to be a 1, right? What about these two things? They cancel. And so all you're left with is a 1 on top, right? A 1 on top. And on the bottom, what do you have? Cosine theta, sine theta. But that's the same as 1 over cosine theta times 1 over sine theta. And by definition, this is secant, and that's cosecant. And that's what we were trying to get to. We're there. Enjoy your homework. All right, do your homework, all right? And when's our next test? I feel like it's still a ways off, but I almost feel like we should have one.